So we have this absolute value function for f of x. We have g of x as a quadratic function, and we are going to use function notation to evaluate them. So what this means here, it means I have f minus g of -1. That is the same thing as saying f of -1 minus g of -1. So I can evaluate both. F of -1 is -3 times the absolute value of 2 minus a -1 plus 1. So that's -3. Absolute value of 2 minus a -1 is 3 plus 1. The absolute value of 3. 3 is 3 units away from 0. So that's just a positive 3 still, plus 1. And then -9 plus 1 equals -8. Now g of -1 is -1 quantity squared minus 5 times -1. So that's going to be positive 1 plus 5. So that equals 6. So now when I find the difference, right, I'm going to do f of -1 minus g of -1. That's going to be -8 minus g of 1, which is positive 6. And so you get -14. G of -3 is -3 quantity squared minus 5 times -3. That's going to be positive 9 plus 15, which is 24. And then f of 5 is -3 times the absolute value of 2 minus 5 plus 1. So that's -3 times the absolute value of -3 plus 1. Well, the absolute value of -3 is 3 units away, so that's -3 times positive 3 plus 1, which is -8. So, so now what I really have then, g of -3 is 24, f of 5 is -8, so the final answer here is -3 when we divide. Now for composites, remember we want to work our way inside out. So if I am trying to find f of g of -3, I need to figure out what g of -3 is. Well, what they're giving us is the x, right? So I have x, so I take a look at -3, and I'm reading it from g. So at -3, g of x is -2. So I'm really trying to figure out what f of -2 is. So now, again, I need to use the x. My new x is -2. So I come over here to -2, but now I'm using my f function, not my g function. So the answer here is going to be 1. G of f of -2 means g of f of positive 2, sorry, not negative. So positive 2 is my x, so I come up here, I find positive 2. Now I'm wanting to go to f, that's my solid function, so that is really g of -3. So f of 2 is -3. I come over here to -3, and that's a positive 3 on my f function. So that's positive 3. Okay, so this is going to work the same way. We have h of k of 0. So x is 0, so I need to find x is 0, and I'm using k to evaluate. When x is 0, k is 2. Now I need to find h of 2. So I come up, x is 2, but instead of using k, I'm going to use my h part of the table, and that equals 0. And this is really k of h of -1. So x is -1, we find that, and I'm evaluating for h. So when x is -1, h is 2. So this becomes k of 2. When k is 2, or sorry, when x is 2, k is -1. All right, now we are going to evaluate functions by just simplifying the expression. So this is really p of q of x. Okay, now p is the outside, and I'm plugging q into p. What is p? P is 2 times my input x minus 1. What is my input? It's q of x. What is q of x? 3x squared minus x. So now I distribute, and I get 6x squared minus 2x, but don't forget about that -1. q of p of x, we're going to do the same thing, but now I'm looking at q. So q is 3x squared minus x. So notice I put parentheses where I want my input to be because my input is the x here. So instead of x, I'm going to put my function p. What is my function p? It's 2x minus 1. Now you have to be especially careful here because we need to multiply this binomial before we multiply by 3. So this becomes, on a side note, we'll just put it over here, this is really 2x minus 1 times 2x minus 1. So I get 4x squared, I get minus 2x is minus 4x, and then negative 1 times negative 1 is positive 1. So what's really happening here is I'm taking 3 times 4x squared minus 4x plus 1, and then I'm going to distribute to get minus 2x plus 1. So this is 12x squared minus 12x plus 3 minus 2x plus 1. Combine your like terms. So I get 12x squared minus 14x plus 4. And then the last one, we're going to do the same thing. We're going to combine the functions, but we're going to actually solve for x so that when we combine them, they equal 0. So f of g of x means I'm going to take my x, so that's 1/2 times my input minus 5. I'm putting in g of x, which is 4x squared plus 6x. So then when I distribute the 1/2, I get 2x squared plus 3x minus 5. And I want this to equal 0 from here. So I'm taking my function, f of g of x, setting it equal to 0, and then I need to solve. Well, this is a quadratic. So there's a couple ways you can do this, but if you're using split the middle, you want to see what multiplies to the outside, so that's negative 10, and adds to, oops, that should be c there, and adds to the middle term. So this is what multiplies to AC and adds to B. So the two numbers that multiply to negative 10 and add to 3 are going to be a positive 5 and a negative 2. So that multiplies to 10, adds to 3. So this is called split the middle because I'm going to rewrite my 3x in terms of 5 and negative 2. So I get 2x squared. Let's do minus 2x and then plus 5x. So this is my 5x and 2x when I split the middle. And then minus 5 equals 0. So this becomes, when I group, 2x times x minus 1 plus 5 times x minus 1. So when I factor out x minus 1, I'm left with 2x plus 5 equals 0. 0 product property, x minus 1 equals 0. 2x plus 5 equals 0. And so I end up with x can be 1, or, this should be 0 here, sorry. If I subtract 5, right, 2x equals negative 5. So then x could be negative 5 halves.